Write inequality using absolute function notation. We have observed that whenever we are working with inequalities, the answer could be represented on a number line. Now, when you represent answer on a number line, it could also be written as absolute function. So that is the process which we are going to learn in this video. So let's start from some solutions of inequalities on a number line. So let us say we have a number line here going like this, and the solution which we get is something like this, that the inequality is true for a duration which is in between two numbers, and let us say these two numbers are -4 and +4. How will you write this as an absolute function? That is what is the question which we need to discuss. Now, some of you know about it, so what you can do is, as I'm drawing and taking my time, you can write your solution, right? So this is the first one, and the second one will be similar to this, and where what we will do is we'll fill in these holes. That means we're talking about something where the endpoints are also included, right? So let's say these values are -3 and +3. Now let's take some examples where the values are not in between, but they are going away. For example, here we can say that the solution is, while we are away at least 5 units minus side and 5 units away from the plus side, something like this. If that is the solution of an inequality, how to represent that as an absolute function? So that is the question which we'll discuss in this video. Another one is very similar to this, and that is, we'll have a number line solution which will have filled in holes, you guessed it right, and they are, let us say, at -7 and +7 moving outwards. That is the scenario. So these are 4 different solutions which we get for some inequality, and we need to write, or rather rewrite, this as an absolute function. How can we do that? So that is what we need to understand. Now let's first have a look at the absolute function itself. Let us say this is my xy coordinate system, and then the absolute function is always positive, you know. So it is kind of drawn like this. Right, so that is the absolute function. We say f of x equals to absolute x. Basically what happens here is that it has a point here. So absolute function has 1, 0, or I should say at one point it has one value. But for any other point, if you consider any other point on this function, any other y value, it will return you 2 values for that particular point. Right? So if I say 5, absolute x is 5. Let us say if I say that we are looking for absolute x equals to 5, that means x could be either +5 or -5, right? That is what we are saying. And if we say that absolute x is equal to 0, that means we are only looking for one value, and we know it is 0. That is equality, correct? It's always good to find equality first and then decide about inequality. That is this philosophy which we are going to use here. Now if I say that something is less than this value, that means it is within that interval. Do you understand? Within that interval it is less than. And if I say that absolute x is actually greater than 5, it really means that, let us say this value is 5 for us. This is just an example. If I say greater than 5, that really means we are looking for a solution which does not include 5, but which is like greater than. So here above this value all are greater than 5, as you can see. Do you see that? So greater than 5 means that. But less than 5 means everything below this line. When you say less than 5, then we are looking for a solution which is inside. That is what we have, which is also same distance away from the vertex. Correct? So that's the philosophy we are going to use. Now if you consider this, and now from here we can straight away write down our answers. So I think the answers are pretty obvious here now. So the vertex will be right at the center, which is 0. And how much away are you? You are 4 units away, and these points are not included. So we can write this as absolute x is less than 4, right? That gives us this kind of solution. Now if these are filled in, so these ones are filled in that case we'll say absolute x is less than 3, right? 3, but equal to also, right? So it's less than equal to. Now in this case what we observe is since the values are included, we are within a range of 3 units. So absolute x is less than equal to 3. Now let's consider these cases. So these two cases we are going away, right? So that means we are talking about absolute x greater than. Greater than what value? Greater than this value 5. Do you see that? So absolute x greater than 5 is the way to write absolute function for this number line solution. And here it will be absolute x greater than equal to 7. Why greater than equal to? Because these points are included, right? So the idea here is first to find the center of this, and when the center is 0, then absolute function is not transformed. So it is just absolute x greater than equal to the value, how far you are, right? So you are 7 units away. So you have to be farther away. That is why it is greater than equal to 7, right? In this case, you are 4 units away, but you want to be nearer, right? So it is less than 4. That is the philosophy to write inequalities in the form of absolute function when the solution is given on a number line. Now in the next video, we will discuss what to do when it is when 0 is not the midpoint, rather something else is the midpoint. So that we will see in the next video. Thank you and all the best.